Hello everyone, my name is Neha. I am a student of BSc Chemistry Honours 5th semester. Today we will perform the experiment to verify Beer-Lemberts law for using KMNO4 solution.
Materials required for this experiment is KMNO4, 5 test tubes, conical flask, distilled water, burette, round bottom flask, and colorimeter. Now we will prepare solution of potassium permanganate in distilled water. Here first of all we will take KMNO4 in round bottom flask, and now we will make its solution by taking distilled water and mixing it well. Now we will fill the round bottom flask up to the mark. Now using the measuring cylinder we will measure 1 ml of KMNO4 and we will mix it into 100 ml of distilled water taken in a conical flask to prepare 0.001 normal potassium permanganate solution. Now we will make different combinations, like for example 1 ml of KMNO4 taken into the first test tube and 9 ml distilled water in this. Similarly, in the second test tube we will take 2 ml of KMNO4 solution and 8 ml of distilled water. Here we have prepared 5 solutions of 1:9, 2:8, 3:7, 4:6 and 5:5 of amount of KMNO4 and distilled water respectively. Now we will standardize the colorimeter using distilled water and will set the device at 0 in the following way. Here we put this distilled water tube in the colorimeter and now we will calibrate the device at 0. Now we will take pure KMNO4 solution and will note the value of absorbance on different lambda. Like on 62 it is minus 2.25, on 54 it is 0.54, on 52 it is 0.59. On 50 0.03, on 48 minus 0.13, on 42 absorbance is minus 0.19, On 40, absorbance is minus 0.23, and on 68 again it is minus 0.18. Here we observe that the lambda max value comes at 52, that is lambda max is 52 at which absorbance is highest. Now we will take first solution with combination of 1 ml KMNO4 and 9 ml of distilled water and measure its absorbance. Next we will repeat the same experiment with other solution, like in the case of 2 ml of KMNO4 and 8 ml of distilled water, then 3 ml KMNO4, 7 ml distilled water, 4 ml of KMNO4 and 6 ml of distilled water, and finally 5 ml of KMNO4 and 5 ml of distilled water. Here we have represented the value of lambda and absorbance in a tabular form as shown. For example, at the value of lambda 40, the absorbance is minus 0.23. At 42, absorbance is minus 0.19. At 48, absorbance is minus 0.13. At 50, absorbance is 0.03. At 52, 0.59. At 54, 0.12. At 62, absorbance is minus 0.25, and at 68, absorbance is minus 0.17. Among these values, we determine the lambda max value, which is obtained at lambda max is equals to 52, which is 0.59. Now here we have represented the concentration of KMNO4 and absorbance in a tabular form as shown. Here 0.001 normal KMNO4 solution has absorbance minus 0.15. For 0.0002 the absorbance is 0.07. For 0.0003 absorbance is 0.05. For the concentration 0.0004 normal, the absorbance is 0.14, and for 0.0005 the absorbance is 0.30. After that we will plot the graph in which we have taken concentration of KMNO4 on x-axis and the value of absorbance on y-axis. Here it is clearly visible that the graph plotted according to the table above is a straight line. Hence, Beer-Lemberts law is verified by this graph.